Hello, and welcome to another episode of AI at Akamai. I'm Vineet from Akamai Cloud, and if you've seen any of our previous videos, you will know that we are big on AI inference. I'm continuing my quest to see what use cases businesses are actually building and how they can turn their AI investments into actual business value. In today's episode, I'm joined by Jay Jenkins, a colleague of mine and also one of our distinguished field CTOs. Jay, welcome. Thank you for taking the time to share your insights with us.
Great. Thanks, Vineet. I'm excited to be here to talk about AI and what's going on.
Great. So on this channel, we love a quirky AI story. And one that I came across a while ago now is one that whiskey lovers, I think, will be interested in. They built an AI to make whiskey. Yep, there's an app for that too. Now, this is a bit of an older story, so I don't think any of the frontier models were used for this particular exercise. This was more a traditional AI and machine learning with data science kind of activity where a whole bunch of data from award-winning whiskeys from the previous 20 years were fed into an AI model. It crunched the numbers and crunched the data and came up with the variables and the parameters that it thinks mattered, and basically created a recipe for the next award-winning whiskey. Now, it didn't win, but I got the chance to taste it, and I thought it was pretty good. So I think it's a win for whiskey aficionados all over the world, and also AI algorithm appreciators. So I'm not going to mention specifically what that product was, because this is not for advertising. But if you are interested in picking up that whiskey, drop me a comment, and I'm happy to DM you, and you can find it. Jay, what are some of the most interesting or unique use cases that you've seen recently?
Yeah, when I think about unique use cases, I always consider this fact that whenever a new technology is introduced, people tend to solve old problems, right? Old problems with the new technology. But I always find it interesting when people find a new problem that couldn't be solved before. And this particular problem actually has to do with bees. So the University of Auckland was trying to help understand what was going on inside of a beehive. For instance, when a queen dies, it obviously has a huge impact on the beehive, but the beekeepers might not know for a number of days that this has happened. So how do you solve this? And how do you solve this using AI? Well, what they did is they took recordings of a beehive, the sound of the bees, and they were able to infer whether or not a queen was dead based on how the beehive sounded. So it's a really unique use case. Not only that, but they actually then started recording other sorts of anomalies where they might not know exactly what that sound was used for or what that indicates in the beehive. But then they started to overlay data around forest fire prediction. So this came out of the University of Auckland, and they were able to actually help infer whether the conditions were ripe for a fire. And so it's, again, an interesting use case. So not only can you use bee sounds to understand what's going on inside of a beehive, but you can also use the sound of bees in order to infer what might be going on in the surrounding environment. So I think this is really interesting, again, not just from a perspective of the bees, but also just the larger perspective that you're able to do things that you couldn't do before using something like AI.
Yeah, that's a fascinating use case. Thanks for sharing, Jay. It seems that every week there's a new announcement from big tech vendors sinking billions and billions of more dollars into training newer, shinier, giant frontier AI models. But did you know that over 80% of the cost to businesses actually comes from AI inference? Of course you did, because we covered that in a previous episode. And if you haven't seen that, I will link that to you in the description as well. Today, we're going to dive into how you can run AI inference more efficiently without breaking the bank. Now, successfully productionizing AI use cases is an obvious marker of success, and hopefully you're seeing business value from that. But there are other avenues to tweaking the value of this equation and extracting even more ROI from your AI investment. And a big one is cost optimization. Sometimes value comes from adding new capabilities. Sometimes it comes from just running your AI more efficiently. At Akamai Cloud, we decided to focus on AI inference a while ago, and we have built up our infrastructure to handle those use cases. As part of our strategy, we chose to invest in NVIDIA's RTX 4000 GPUs from the Ada generation, which is one of the chips that we offer in our accelerated compute portfolio, which includes different GPUs, CPUs, and VPUs. Now, the RTX 4000s were selected specifically for their balanced performance. It packs enough punch to run most inference workloads, but does so cost efficiently. And that's because it's designed to run with just enough memory to handle meaty AI tasks, and it can be grouped together with other RTX 4000 GPUs when you need more raw power or the need to scale. So why does this matter for inference? When you're scaling your AI applications to service many requests or customers, then the costs will begin to escalate. Optimizing performance and cost at scale can then drastically impact your bottom line. And that means you can pass on savings to customers, you can reinvest in more iterations to improve the quality of your model, or you can fuel further innovation. So Jay, can you shed some light on the RTX 4000 GPU specifications and the types of use cases they might be suited for?
So the RTX 4000 Ada GPUs have 6,144 CUDA cores and 192 tensor cores, which are specifically for AI. They also have 20 gigabytes of GPU memory and a memory interface of 160 bits with a memory bandwidth of 360 gigabytes per second. So what does all of this mean? Why is this important? So as you stated, you really need to find the right kind of model for the right kind of profile of card. Now, what we found often when we're talking to customers is they've over-provisioned. They always want to use the biggest and best GPUs, thinking that it provides the best performance, but that is not the case. What you really need to do is right size the right kind of GPU and the right array of GPUs for that specific model. Maybe it's not even GPUs. Maybe you want to do inference on CPUs. Often people forget that you can just use CPUs for inference as well. So it really is about thinking about efficiency of the model, optimizing those models even outside of the processor being used, and then operationalizing that. And as you said, 80% of cost is based around inference, and people need to treat AI projects, in particular the operational side of AI, just as they would any other project. And that is around right sizing and making sure they do that efficiently so they can actually take that money that they save and put that back into R&D.
Great. Now, Jay, you worked on a report that we published earlier in the year called AI Inference, Spend Less and Do More. And that benchmarks the performance of the RTX 4000 ADAs against equivalent GPUs on other cloud providers. For the viewers, the report will be available for download in the description if you want to follow along. But Jay, tell us more about the report and some of its key findings.
Sure. So for this specific report, we use Stable Diffusion XL, which is a generative AI model for images. We chose this model because a lot of customers were using this, and it is often over-provisioned. What we learned out of this study was that by using the right kind of processor for the right kind of model, you're able to save massive amounts and still maintain performance. So for this particular study, we compared it against AWS T4 instances and AWS A10G instances. Now, to be fair, we could have actually used any sort of GPU for this model, but it's the exercise that you need to go through with your AI teams and understanding of what the AI model requires. That's the important bit to understand here. And while all of these are recommended processors for Stable Diffusion XL specifically, what we found is you can have vast amounts of differences for performance and cost. As a part of the study, we tested, of course, latency. And what we found is by using the RTX 4000 Ada GPUs, we're able to decrease latency by 15% when compared to AWS A10G instances, and by 62.8% versus AWS T4 instances. In addition, we're able to increase the throughput. So we can run the model and get an increase in throughput by 29.4% versus the AWS A10G instances, and an increase in throughput of 314.3% versus AWS T4 instances. And for iteration speeds, which are extremely important for models like Stable Diffusion XL or any sort of generative model which requires multiple processes, we were able to increase the number of iterations to 20.08 iterations per second as opposed to 18.11 iterations per second on A10G processors and 7.5 iterations per second on T4 processors. And the most important thing is that not only were we able to increase the performance, we were also able to drastically reduce the cost. So running the Stable Diffusion XL model on the RTX 4000 Ada GPUs cost 58.4 to 75.5% less on the AWS A10G instances and 76.9% to 86.4% less on the AWS T4 instances.
86% is nothing to scoff at. So I think most people are familiar with latency. That's how long it takes to deliver the outputs. But maybe you could talk us through defining throughput and speed in the context of the Stable Diffusion use case that you mentioned. And maybe you can add some color here in terms of business use cases that may benefit from this.
So throughput is actually, for Stable Diffusion, is how many images can be generated in a given period. So here you're really talking about the throughput of the GPU. So it's not necessarily about the end user experience for a single customer. It's about how much can you actually do for the multitude of customers that you might actually have. Now, iterations are very specific to models which require multiple iterations, because iterations themselves actually define the quality of the output. So if you've used any sort of image generation model before, some of those will actually show you those interim iterations, right? So you get a blurry image and over time, it slowly sharpens. So those are our two qualities specifically for Stable Diffusion, but not exclusive to Stable Diffusion. Throughput specifically is important for any kind of model that you're working with, because you're really talking about production. You want to understand how much you can service via that GPU. And to the second part of your question, sort of what are the business use cases for this? So Stable Diffusion and image generation, we have a number of customers using that, and I don't think that particular model needs any sort of specific expansion. But what I will say is, even outside of that model, we've seen significant savings. A good example of this is we have a customer using our RTX 4000 Ada GPUs for voice AI, and they've seen a 40% cost savings above their previous GPU, and they are also getting better performance. So it really is about talking to your teams and figuring out what is the best processor for the type of model you're trying to implement. You also need to think about things like whether latency is important for you. Perhaps you're doing a batch type job that can be done overnight, generating sales leads for your organizations using AI. All of these models need to be taken into consideration for their specific use case, what's required of it in order to find the most efficient processor possible in order to implement that.
Right, thank you. That makes sense. So higher performance metrics means you get to do more with less. So in summary, at Akamai, we're proud to deliver an AI cloud platform that puts inference first, and we've intentionally focused our investments on enabling customers to deliver AI inference affordably and efficiently. Ultimately, it's about delivering balanced performances for businesses and giving them the choice to choose what is right for them. Jay, thank you so much for being here. We appreciate your insights. And with that, it's time to wrap this episode. I hope you enjoyed unpacking the RTX 4000 GPU and the benchmarking report showing that AI inference doesn't have to cost a fortune. You can spend less, do more, and keep your AI performance strong. Let me know in the comments if you found this interesting and if there's any specific topics that you'd like me to unpack in a future episode. Thanks for watching, and I'll see you next time.